Hey, good morning, afternoon, evening, whenever you're listening to this. Hope you're having a good day. You should have your note sheet, 4.1 note sheet. We're going to start with a quick review of yesterday. Remember we talked about a radian. It says the measure of a central angle theta that intercepts arc S equal to the length of radius of the circle. Okay, so let's be a smarty and let's label on our picture, let's label our radius, our arc. That gives us 1 radian. See if you can do that real quick. We want the radius. Oh, that one's pretty darn easy. There's our radius. Now put that put that arc length with the same distance on the circle. Should have copied about the same distance. Remember that arc length S will be the same distance as that radius. I tried to mimic that distance. Those are supposed to be the same distance. If I do that, and I create my angle, this angle, that central angle we created, that's what 1 radian is. So from our Smarty Lab the other day, that's what we figured out. All right, so now we have a warm-up. What's the measure of the central angle? 10 Smarties for our radius, 20 Smarties for our arc length. Correct, 2 radians. Hopefully you had that right, because if it's 20 Smarties, if this is 10, if that's a radius at 10, then there's a 10 and another 10. So that gives us 2 radii along that arc. So my angle gives us 2 radians. Cool. So we're going to talk about radians a lot in pre-calculus. We got to get used to that radian thing. But before we do that, we're going to go off of that just a little bit. We're going to go away from it just a little bit and do some other things, talk about some stuff. All right. First, we're going to talk about, hey, we have to be able to understand, hey, degrees and radians degrees, how they're related and about the same size. So let's do that. First, let's talk about factor label. We all like chemistry. Remember factor label back in 9th grade or in chem? We're going to do that when we're talking about going from degrees to radians. So first one should be easy, 6 inches, 6 feet. We probably already know how many inches, but let's see how we do that factor label. We go 6 feet, and I want to multiply it by something that's equal to 1, and I'm like, oh, there's 12 inches in a foot, but we need to make sure that our units cancel. Keep thinking about units. So if I want my units to cancel, I know I need that 1 foot on the bottom and that 12 inches on top. So my feet cancel top to bottom. So I just do 6 times 12, and that's 72 inches. So you guys try number 2. 32 quarts equals how many gallons? Oh, you're thinking how many quarts to a gallon? That would be 4 quarts to 1 gallon. Go for it. Should have put quarts on the bottom, gallons on top. Why do I know quarts go on the bottom? Because my quarts cancel. So now I'm just doing 32 divided by 4. We all know that is 8. Fantastic. All right, so now we're going to do the same deal with this. We got to figure out where's Linz's scroll button. Oh, there it is. All right, I'm on Linz's computer, so I got to have to think for a minute. All right, so now I'm going to do the same deal with this example 1 here. We're going to go after this 90 degrees. But think about 90 degrees. We got to figure out what's that fraction that's equal to 1 dealing with radians and degrees. Oh, I remember that from yesterday. What did we come up with? We said that, 180 degrees is the same as pi radians. That's what we came up with yesterday. So that 180 is pi radians. So that fraction is either going to be 180 degrees over pi radians or pi radians over 180 degrees. I just got to figure out which one's which. How do I tell which fraction to use? Do I put the pi on the bottom or do I put the pi on the top? When I come over here and I look at number 1 with that 90 degrees, I'm like, oh, I got to go 90 degrees. I want to multiply it by something that equals 1 to get rid of that degrees to go to radians. Oh, degrees is on top. I want a degrees on the bottom. So I got 180 on the bottom, pi on top. Now I take a look at my units and my degrees cancel. hey, not only the degrees cancel, but also the zeros cancel. So now I got 9 pi over 18. And 9 over 18 we know as pi over 2. And yesterday we saw that 90 degrees is the same as pi over 2. If you remember that from yesterday, that right angle. I was halfway, or a quarter of the circle was 90 degrees. All right? So you guys try we'll do 315 together. So same deal. I'm going to do 350 degrees times pi over 180. How do I know to put 180 on the bottom? Degrees cancel. A little harder, I'm like, ooh, 315 over 180. Got to think a little bit. Let's see, 315 over 180. What can I divide both of those by? Oh, I definitely can divide both by 5, and then we can do a little bit more than 5, and we can keep going and see what you guys come up with. Oh, forgot my pi. I come up with 7 pi over 4 when I do all that division. Cool. You guys try 210. Hit pause, go for it, see what happens. Welcome back. Hopefully you did this. Degrees cancel, zeros cancel. That gives me an 21 over 18. Divide both by 3. I get 7 pi over 6. And holy cow, that makes a whole lot of sense to me, because if I think about 210, if I think about where 210 is, all right, on my circle, 210 is just past 180, right? Okay, so right, because there's 180, so 210 is somewhere in there, right? Okay, that's about 210. And then if I think, oh yeah, well, we did this with radians, pi radians. If I start here with 0, pi radians halfway, so it's a little bigger than 1. Isn't 7/6 a little bigger than 1? Yeah, it's 1/6 bigger than 1. A little bit bigger. Nice. All right, so now let's go the other way. Now let's go radians to degrees. Oh, well, same deal. Factor label, pi over 6 times, but we want to get rid of the radians and go to degrees, so I want the degrees up top and the radians down below. Because now my pi's cancel, so that just gives me 180 over 6. 180 over 6. Oh, that looks like 30. Oh, so pi over 6 is 30 degrees. Get used to that one. We're going to use that one a lot. You guys do number 2. Go. Hit pause. Welcome back. Hope you did something like that. So we got, 2 goes into 180 one time. That would be 90. 9 times 9. Oh, that looks like 810 degrees. 810 degrees? How is that possible? Oh, 360 is 1 revolution. 720 is 2 revolutions. So a little bit more than 2 revolutions. Oh, we can go around the circle more than 1 time. You betcha. All right, a little different for number 3 here. We got 3 radians. I'm going to deal with the same deal because it's a radian. So we have this radian, so I'm going to multiply it by 180 degrees over pi radians. Remember, pi is that radian deal. So we're going to cancel the radians. Oh, but I can't cancel that pi in this case. Oh, so I'm going to do 3 times 18. 3 times 18 is 540. So I get let's just do it up here. I get 540 over pi. That's the exact answer. So that's the one that I like. There's a degree. That's fantastic. If I take out my handy-dandy calculator, hit 540 divided by pi, I should get 171.88 degrees. Ooh, that should make a whole lot of sense to us also, because if I think about when I did that Smarty Lab, you guys were not comfortable when you did 1, 2, 3. Remember that 3 radians sort of deal when you did that Smarty 3 times and you didn't get quite to that 180 and you thought you had a mistake? oh, but 3 radians is a little bit short of 180 degrees, right? It's not quite. So that makes a whole lot of sense that it's 171.88 for 3 radians because it's not quite 180. All right. So that should make a whole, oh, that's 2 radians there, and this one is 3 radians. So that should be pretty good there. All right. Then the other day we saw how big number 4, how 1 radian is. But if you remember that 1 radian times 180 over pi. Oh, so I just hit my calculator, 180 over pi. So if I wanted the exact answer, 180 over pi, or I divide 180 by 3.14 about, and I get about approximately, I mean, that was not quite 60, 57.3 degrees. Cool. Oh, both of those. All right, so now we can go from radians to degrees, degrees to radians sort of deal. Something you probably don't know, but we have a degree can be divided into more units, okay? Just like we can have like a meter divided into centimeters, divided into millimeters, or yards to feet to inches, we can get smaller units. A degree we actually can divide up into smaller units, all right? So additional degree measures, 1 degree is the same as 60 minutes. And we write that as 60 minutes with just a hash mark. And then 1 minute, I read this as 1 minute right over here. That's 1 minute sitting there. 1 minute can also be divided into 60 seconds. So I can take this degree, over here, and I can divide it into 60 little parts. And all those little parts are called minutes. And then I take one of those little parts, one of those real small minutes, and they're all divided into 60 seconds. And how do I write seconds? I do 2 hash marks, so it looks like a quote. All right, so another way to write things, you might, oh, I'm not there yet, sorry. So if I think about 3,600 seconds, 60 times 60, 60 times 60 is 3,600, so 3,600 seconds is equal to 1 degree. So I can divide this degree, this little thing called a degree, and divide it into 3,600 little parts, and one of those parts is a second. All right, so now we're going to have to deal with changing units or a changing kind of deal. This one says, hey, we want to express as a decimal degree measure. So right now we have 245 degrees. This says 10 minutes. So right now we have degrees and minutes, and I want a decimal. All right, so I know my answer is going to be something like 245 point something. How do I know that? Oh, it says 245 right there. I just got to figure out what the decimal part of that 245 is. How can I do that? Ooh, I can take this 245, we already know what that is, and this is 10 minutes out of 60 minutes. 10/60ths. So I hit my calculator, 10 divided by 60. So I'm going to go over here, I'm going to grab that calculator, and I hit 10 divided by 60, and I get this 1.66 repeating kind of deal. It keeps on going forever. So that gives me as a decimal 245 plus 1. Sorry, that's not 1 point. I lied to you. That's 0.16 repeating. Put that in the wrong spot. Sorry. So my decimal is 245.1, and we can go, if I went around to nearest tenth or hundredth, we can go 0.17 and that's degrees. So I stumbled a little bit on that one. Sorry. Let's go after number 2. So, first of all, we have 148 degrees, 16 minutes, 25 seconds. So if I want a decimal, I know it's 148 point something. I just got to figure out what that something is. Well, the first thing I'm going to do is I'm going to take that 16. Okay. well, I guess on my calculator, this is what I'm going to do. I'm going to take that 148. If I want to hit the 148, I don't really need to. But I just want to add, hey, it's 16 out of what? Oh, 16 out of 60. And then it's 25 out of what? Out of degrees. We remember we want these things in degrees. So it's 25 seconds out of 3,600. So I hit that on my handy-dandy calculator, and then I round that off. And you guys can have the calculator. I'll give you a second. Hopefully you got 0.27 of a degree. Okay, so it goes from minutes to seconds. Sorry, goes from degrees, minutes, seconds to decimal degrees. We take the minutes, divide it by 60, take the seconds, divide it by 3,600. Why? Because there's 60 minutes in a degree, and there's 3,600 seconds in a degree. All right, fantastic. Now we're going to go the other way. We're going to express as degrees, minutes, seconds. So we're going to go the opposite. So now I give you a degree, and I want to go to degrees, minutes, seconds. So I want my answer to look something like the last one. So my answer is going to look something like that, where I have that degrees, minutes, seconds, and that one's just the degrees, minutes. We might have seconds. So what do we know? Oh, well, right away, we know that we have, what, 345 something. Okay, so we know we got that 345 degrees. We just got to figure out how many seconds and how many minutes. So I think about that 0.12 of a degree. Oh, well, there's 0.12 of a degree out of 60 minutes. So I can multiply those two, because this is, if I want to think factor label, I can actually think factor label on this, because that's a degree. And then here's 1 degree, and this is 60, oh, not seconds. Let me grab my eraser, but actually 60 minutes. So that would be a minute. So that's why this all works, because we can do that factor label, because my degrees cancel. So I do 0.12 times 60, and we get that 7.2. And that's 7.2 of a minute. So this gives me 7 minutes. So now that 7 goes up here, and now I have to deal, so I've already used that part up, so now I got to use the 0.2. Oh, well, what do I know? It's 0.2 of a minute, and I want to multiply that by 60 seconds in 1 minute, because my minutes now can cancel. So I'm just doing 0.2 times 60, and 0.2 times 60, we can do that, I think, in our head, and we get 12 there. What color am I on? Blue. And we get 12 seconds. Purple. 12 seconds. You guys try number 4. Why don't you hit pause, see what you come up with. Welcome back. Hopefully you have 215 degrees something. Not sure about my minutes, not sure about my seconds yet. We should do 0.63 times 60. 37.8 minutes, so that's a 37 minute. Then I'm going to take this 0.8, I'm going to look at this 0.8, I'm going to do a 0.8 times 60, which gives me a 48. So hopefully you got that. Alright, fantastic. Hope that went okay with you. We're going to finish up this note sheet tomorrow. If you want to, actually, you can work on the next one and see if you can figure some things out. I'll have another lesson posted tomorrow to see what's going on there. So good luck. If I went too fast, go back, take a look, make sure you can do all those. Hope you have a wonderful afternoon. Goodbye.